Alright, in this video I'm going to be doing some power rule examples and working through BC Homework 2.1. So the first set of problems is kind of just like find the derivative. Okay, so I think what I need to remind you of, the kind of the big moral of the lesson, was that the derivative of a power of x with respect to x is that power times x to one less power. So if I've got f of x equals this, well, okay, hold on. These aren't written as powers, okay? We can think about that as 1x to the 0 if we like. This is x to the negative 1. This is going to be x to the negative 2, and that's going to be x to the negative 3. Okay, so when I take the derivative, I'll have f prime of x equaling the derivative of x to the 4 is going to be 4x to the 3. Derivative of x to the 3 is going to be 3x to the 2. Derivative of x to the 2 is going to be 2 times x to the 1. The derivative of 1x is 1. The derivative of 1 is 0. Derivative of x to the negative 1 will be negative x to the negative 2. The derivative of x to the negative 2, positive x to the negative 2, will be minus 2x to the negative 3, and then minus 3x to the negative 4. Okay. Now we're going to, we're going to have to rewrite this with y equals 4x to the 3, 3x to the 2, 2x and 5. Those are fine, but I'm going to have to take this cube root x, and I'm going to write that as x to the 1/3 power. Then I'm going to write this as minus 2x to the negative 1 and negative 3x to the negative 2. So that when I go and take the derivative, I'm going to get 12x squared plus 6x plus 2 plus 0 plus 1/3 x to the, okay, I'm going to reduce the power by 1. I'm going to subtract 1 from the power. So 1/3 minus 3/3 is negative 2/3. And, okay, this derivative will be plus 2x to the negative 1 minus 1 is negative 2. And this will be plus 6x to the negative 3. All right. Another fact that you learned was that the derivative of sine of x with respect to x is cosine x, and that the derivative of cosine of x is equal to negative sine of x. Okay. So if I'm taking the derivative of 3 cosine x, it's going to be 3 times the derivative of cosine, which is negative sine. So it'll be negative 3 times the sine of x minus the derivative of sine is cosine, so minus cosine. Okay, now I'm a little concerned here. I'm going to have to write this as x to the 2 divided by 5. Remember, the square root is the 1/2 power, so the 5th root will be the 1/5 power. And so when I take the derivative of x to the 2/5, I'm going to have 2/5 x to the 2/5, and I'm going to subtract 1. I would think 2/5 minus 5/5 is going to be negative 3/5. Then, okay, over here, okay, h prime of x will be, okay, 3 times the derivative of sine of x. Then the derivative of cosine is negative sine x. And then we'll subtract 2x. Okay, find the values using the functions from numbers 1 through 4. Oh goodness. Number 1 is f. That's kind of a lot. So what we're going to do is we're going to take f prime and we're going to plug in 1. Well, I'm just going to have room to do that down there because there's just too many terms. So I'm going to go over here and I'm just going to kind of plug in on f prime of 1 up here. So it's going to be 4 plus 3 plus 2 plus 1 minus 1, because any power of 1 is going to be 1, right? So minus 1 to the negative 2 is just going to be minus 1. So minus 1, minus 2, minus 3. Oh, so it's 4. is going to be 4. dy dx at x equals 1. Let's see. Let's make sure. Yeah, we can get that up here. And so I'm going to squeeze that in red at x equals 1. Yeah, is 12 plus 6 plus 2 plus 1/3 plus 2 plus 6. All right, I've got 8, 16, and 12 is 28 and 1/3. Wait, no, that's not right. That's 18, 20, 28 and 1/3. Okay, 28 and 1/3, whatever. Hold on. It's going to be 84, 85 divided by 3. I think. All right. G prime of pi, okay, when I plug in pi up here, I'm going to get, let's see, -3 times the sine of pi minus the cosine of pi plus 2/5 of pi to the -3/5. All right, well, I'm just not going to be able to do anything with that, and I'm going to have to figure out what is this. Okay, this is -3 times 0, so that's 1 plus, so 1 plus 2/5 of pi to the -3/5. Okay, that's an exact answer. That's as far as we're going to be able to go. Okay, h prime of pi over 4 is going to be, is 3 times the cosine of pi over 4 minus the sine of pi over 4 minus 2 pi over 4 is pi over 2. Okay, maybe you're needing a little support on how to determine sine and cosine of pi over 4. Okay, I'm going to say, okay, the over 4s, those are the ones with the 45-degree reference angle. So it's going to, and pi over 4 is less than pi over 2, so it's going to be over here. And it's going to be the one that's like 45 degrees. And on the unit circle, all of the triangles have hypotenuse 1. And with the 45, 45, 90 triangle, this is √2 over 2, and that's √2 over 2. So cosine on a SOHCAHTOA level is going to be √2 over 2 divided by 1, and sine will also be √2 over 2 divided by 1. So I'll have 3 times √2 over 2 minus 1 times √2 over 2 is going to be 2 √2 over 2s. So this is going to be the square root of 2 minus pi over 2. Next, we're going to write an equation for the tangent line to this function at a given x value, and we're good at that. We just need a point and a slope, and then we're going to write our equation. Okay, so first I will need a point. 1, and when I plug in 1, I'll get 1 plus 2 is 3 minus 3 is 0. Okay. Well, what is dy dx? That's going to be 2x plus 2. So the slope will be 2x plus 2 with x equals 1 plugged in. So that'll be 2 times 1 plus 2 is equal to 4. So the equation is going to be y minus 0 is equal to 4 minus 1. Then write the equation of the line tangent to the graph of f of x equals cosine x at x equals pi over 3. Okay, so, all right, let's get ourselves a point. X is going to be pi over 3, and y is going to be the cosine of pi over 3. Okay, the pi's over 3, those are the ones with a 60-degree reference angle. They're the ones that go real high or real low. So it's going to be, I don't know, maybe up here. So we know it's one of these tall triangles, one of the longer ones. That means it's a 30, 60, 90 triangle. And on the unit circle, we know that all of the triangles have hypotenuse 1. And for one of these 30, 60, 90 triangles, the short side has length 1/2, and the long side has length √3 over 2, because because the square root of 3 is bigger than 1. Okay? So the cosine of pi over 3 is going to be 1/2 divided by 1. Okay, to get the slope, I'm going to need the derivative. And we know the derivative of cosine x is negative sine of x. Okay, so my slope this time is going to be negative sine of pi over 3. Well, what is the sine of pi over 3? That's going to be opposite over hypotenuse. That's root 3 over 2 divided by 1. So that'll be negative root 3 divided by 2. And so I'm ready to write my equation. That'll be y minus a half equals negative root 3 over 2 times x minus pi over 3. All right, now find the equation of the line tangent to y equals negative 3x to the 3 plus 2 over x to the 2. Okay, well, I'm going to need to rewrite this as power so I can use the power rule to take the derivative. So plus 2x to the negative 2. That's going to be a good place to start. So the equation of the tangent line, I'm going to need y prime, or dy dx first. So that's going to be negative 9x squared minus 4x to the negative 3. This looks like it's going to be kind of rough numerically, but we'll see. Maybe it'll work out. Okay, so the point is x equals negative 2, y equals negative 3 times negative 8 is positive 24 plus 2/4. Okay. I might just write it like that. It's interesting. The slope is going to be negative 9 times 4 is negative 36. I'm going to need to keep track of this. So negative 9 times 4 is negative 36, minus 4, and then negative 2 to the negative 3 is going to be 1 over negative 8. So, okay, plus 4/8. So that's negative 35.5. Okay. And that means that the equation is going to be y minus 24.5 equals negative 35.5 times x minus negative 2. That's interesting. In the next problem, okay, they're going to say slope of the tangent line equals 4. Okay, so this is going to be, I think this is starting to be where the homework starts to kind of pick up. This is only 3 pages long. So this is where we're going to start to see more excitement. And we're going to have to kind of like unpackage what they're saying. This is just going to be like solving, okay, slope of the tangent line, that's f prime of x, is 4. So I need to just solve this equation. I can do that. So f prime of x equals, well, if f is x to the 3, that's going to be 3x to the 2. And we're interested in where this is equal to 4. So I'm going to set 3x squared equal to 4. X squared is going to be 4/3. And x is going to be 2 over the square root of 3, or maybe negative 2 over the square root of 3. Because these are both numbers that if I squared them, I would get 4 over 3. And just remember, just your kind of daily reminder that in this class, we don't have to, like on the homework or on the quiz or on the free response section of the test, we don't have to rationalize this denominator. But on the multiple choice section of the test, we do have to recognize that this is the same as 2 root 3 over 3. Okay. You need to be able to do it or recognize that they're equivalent. Okay. Find the equation of the line tangent to that while also being parallel to this. Okay. So, first of all, we don't really have much use for lines written in this form. So I'm going to call that y equals 4x plus 3. Okay. Parallel to means same slope. So when is the slope of the tangent line 4? Right? When does it have the same slope as this? So I'm solving for dy dx equals 4. So over here, I'm going to write down my formula for dy dx. It's going to be 2x minus 6 plus 0. And, well, when is that going to equal 4 is what I'm interested in. So I'm going to add 6, and that'll be 10, divided by 2, and I'm going to get x equals 5. So I can say, oh, okay, now I've got the slope, right? I need the point. I've got the x coordinate of the point. The y coordinate is going to be x squared is 25 minus 30 is negative 5 plus 2 is negative 3. Okay. So my point is 5 and negative 3. My slope is 4. Therefore, my equation is going to be y minus negative 3 equals 4 times x minus 5. Find the equation of the line or lines tangent to y equals x to the 3 plus 4x minus 1 and parallel to this line. Okay. So I bet this one's going to pull back 2 of them because the derivative is going to be a quadratic, and when I solve this equation, I'm going to have 2 solutions, I bet. That's what I think is going to happen. But so basically what I'm looking for is parallel to that means I need dy dx to equal 16. But I bet we can make that happen. So over here, I'm going to say dy dx equals 3x squared plus the derivative of 4x is 4, and the derivative of 1 is 0. And we're going to be interested in where that's equal to 16. Okay, so I'm going to subtract 4, and I'll have 3x squared equals 12, meaning x squared has to be 4, so x could either be 2 or negative 2. Okay, we've got the slope. Okay, now we just need the y coordinates. Okay, so y of 2 is going to be 8. 8 is 16 and 1 is 17. Y of negative 2 is going to be, I plug in negative 2 and I'll get negative 8 minus 8 more is negative 16 plus 1 is negative 15. Okay, so I've got my points, I've got my slope. My equations are going to be y minus 17 equals, slope is 16, times x minus 2. And also over here, y minus negative 15 equals, still the same slope of 16, same slope, parallel to that one with slope 16. So, and then x minus negative 2. And that's my equations of the tangent lines that are parallel to the other thing. Right, then I'm going to find the value of k for which the line, this line is tangent. Okay, yeah, this is the one that I was thinking was going to happen sooner. Okay, so what we're going to do is we are going to say that if the line y equals negative 2x plus 3, say it looks like that, and kx squared minus 2. I don't know if it's going to be a parabola like that or the other way because we haven't solved for k yet. But my point is that if this line is tangent, then they need to have the same y coordinate and the same slope. Okay, so same y and the same slope. Right? Same y prime. So, if this is the actual tangent line to the graph of y equals kx squared minus 2. All right, so we know that we need to set the two y's equal to each other. So I need to have negative 2x plus 3 equal to kx squared minus 2. But this is one equation with two different variables in it, so I'm going to need more info, right? So what I need is I need the derivative. This is the same y's, right? I set the y's equal to each other. Okay, what I'm going to need to do is take y prime, that's negative 2 there, and then over here, y prime is 2 times k times x minus 0. Okay, this is negative 2 plus 0, because the derivative of a number is 0. I'm just reminding you of that. All right, so now I'm going to take y primes, and I'm going to set them equal to each other, because they got to be the same. And so I'm going to say, you know, like that's got to be true. And I need negative 2 to equal 2 times k times x. Okay. So what I'm going to recommend doing is, I haven't solved a system. This is a nonlinear system. So you kind of just, with nonlinear systems, you kind of just got to do the best you can. We can't really use substitution and elimination. I guess I am going to be substituting, but not substitution and elimination in the same like Algebra 1 sense where you have systems of linear equations. Okay, I'm going to solve for k and plug in right there just because I think that would be easiest. Then I'll find my x value, and then I'll use that to find k later. Okay, so I'm going to say, first I'm going to divide both sides by negative 1, or by 2. And so I'll have negative 1 equals k times x, meaning that k is negative 1 divided by x. Okay. And I think that's going to be kind of nice. It's going to fit in nicely because if I have negative 1 divided by x and I multiply by x squared, well, that'll work out all right. So now I have negative 2x plus 3 equals negative 1 over x times x squared minus 2. Well, this is going to be negative x. I'm going to add over these two x's, and I'll end up with positive 1x. I'll add over this 2, and I'll get a 5. Okay. Then I'll have the value of k is negative 1 over 5. Okay. And that's how I solved that. All right, let's move on to the next page. All right, the function f equals bx squared minus 2x has a tangent line at x equals 3 that is parallel to the line that connects the points 3, 8, and 1, negative 4. Okay, so basically the slope of the tangent line is the slope between these 2 points. So I need to be finding out the slope. So basically f prime of x needs to equal 8 minus negative 4, y2 minus y1, divided by x2 minus x1, 3 minus 1. So you got 12 divided by 2, that's 6. Okay. So I'm just looking to solve the equation f prime of x equals 6. So first I need to take the derivative of f to get f prime of x. F prime of x is going to be 2 times b times x to the first. So 2bx. And then the derivative of negative 2x is going to be negative 2. So actually, hold on, I didn't even read that close enough. Has a tangent line at x equals 3 that's parallel to the line that connects those points. So not only do I need f prime of x to equal 6, I actually need f prime of 3 to equal 6. And I can't find my whiteout tape, but I'm just going to scratch that and write in 3. Okay. So f prime of 3 equals 2 times b times 3, that'll be 2 times 3 is 6b, minus 2, and I need that to equal 6. So I'm going to add the 2, and I'll get b is 8 divided by 6. All right, I only got this problem left, and the fire alarm's going off because I think they're doing maintenance on it right now, so you'll just have to pardon me. Okay, in the last unit, we saw how to make a function continuous, right? If it was defined in 2 pieces or multiple pieces. We would set the pieces equal to each other and plug in the x value of the point that they shared, or where they split. Maybe they didn't share it, but we wanted them to share that xy point if it was continuous. But then at the end of the last unit, we also learned that, you know, if we had something like that, that wasn't differentiable. So what we need to do now is we need to make sure that not only are these pieces of graph meeting up, but they're meeting up smoothly. So what we're going to need is we're going to need to have a situation where, you know, maybe it's coming up like that, but it has the same slope at the handing off point. Okay, so what we're going to do is we're going to set the 2 pieces equal to each other, and then we're going to set the 2 pieces of derivative equal to each other. So I think the first thing I'm going to do is take the derivative. So this will be a plus 0, and then over here I'll have 6x. Okay? And for x being less than 2 and x being greater than 2. Okay. Now, ideally, we want a to be equal to 6x so that these meet up, and one of these is less than or equal to, but in general, when you take the derivative of a piecewise function, you're going to lose your less than or equal to's. So what was I thinking here? Oh, when I plug in x equals 2, I need a to equal 6 times 2, which is going to be 12. So I need a equals 2, which means a equals 12. Okay. Now I need the two pieces of graph to equal each other. I need them to meet at the same y-coordinate. So I'm going to set them equal to each other. So a is 12, so 12x plus 5 has to equal 3x squared plus b, also at x equals 2. And so that would be 24, and 5 is 29, equals 3 times 4 is 12, plus b, leading me to think that b is going to be 17. Okay. One more of these. And I'm going to take the derivative, just like I did before. All right, so that I need these to, okay, so, you know, x less than 1, x greater than 1. I need these two things to be equal to each other. So I need 2ax plus b to equal 0 at x equals 1. So that's 2a plus b equaling 0. Okay, but that's one equation with two variables, so I'm going to need more information to work off of. So what I'm going to do is I'm going to set the two pieces of graph equal to each other at the point where x equals 1. So I need ax squared plus bx to equal 3 at x equals 1. So I plug in 1 and I get a plus b equals 3. And I get 2a plus b equals 0. I'm going to just subtract this equation right here. And we get a minus 2a is negative a equals 3. So that feels to me like a needs to equal negative 3, and a plus b equals 3, so that means b has to equal 6. Okay. Yeah, and I don't have any extra practice problems that I've assigned for this particular lesson, so that's going to be all for this video.